Hi there, welcome back to the breadboard. In the previous video I stated that I would show you how to do a few Christmas light kind of effects using some simple LEDs and components that you can get from quite a lot of places, including Banggood, Amazon, and lots of other your favorite shopping places. And what I've got here running right now is one of the lighting displays that I had done a few years ago for a competition, in which I ended up winning a 3D printer, would you believe, which was kind of nice. This is using some LED displays. They're not quite the same as the ones that we were using in the previous video, which were these ones here. I'll turn the lights off right now, by the way, so that you can see this a little better. In the previous video we were just using an RGB LED. Now what this is running, and it's actually running a sequence that I wrote up at the time, is what they call WS2812 LEDs. This little board here that's attached to this Arduino R3, it could be any Arduino R3, or it could even be an ESP8266 or something like that. You can see 10 white chips on here. What those white chips are WS2812 LEDs. I'll put up a zoomed up picture of one of them on the screen here so that you can see. But let me just go into you can see here we've got the WS2812s on this board. There's 10 of them. What is inside this star are 5 of these little boards, and they're wired in series. So it comes out of one into the next, out of one into the next. And these, when they come in a different form, are called LED strips. It's one of the favorite terms for them. Strip lights, LED strips, rope lights, etc. They come in a number of different forms. These ones are on a board that a friend of mine made up quite a few years ago, and I got him to send some over to me. And what these are, you can actually put a little microcontroller on the back of them. It's a tiny little place right here for it, and you can put an AT tiny chip on it. It only has a few I/O pins, as you can imagine, because it's only an 8-bit device, but it's enough to be able to drive one of these. We were looking at the 328 on here, or the ATmega 2560 on here, which has got, you know, about 86 I/O pins, 20 odd I/O pins, and then the chip that will go down the back of here has got like 4 or 6 maybe, depending on how you configure it. The one thing they all have in common is they're all programmable from an Arduino IDE. They're all using Atmel, or now Microchip, microcontrollers on there as well. There's a lot of commonality between them, and they're all able to drive things like this display. This is another display that my daughter and I put together. It's fallen apart a little bit now. What you've got is a couple of eyes, let's call them eyes for the minute, but rings of WS2812 LEDs that form eyes for this little minion here. The kind of nose area is formed from an ultrasonic transducer, and then the mouth, which looks like it's got a sucky in it, is formed from, just zoom out a little bit, a motion sensor. So on the back of this, all right, you can see all the parts here. We've got the electronics for the ultrasonic distance sensor. We've got the motion sensor parts, and we have a little board here with an AT tiny microcontroller on it. I've just bored out the pins, and I've got the WS2812s here running from one output pin. There's one pin from here apart from power. Actually, there's 2 pins from the ultrasonic. You've got a trigger and a response that goes into here. So you've got 1, 2, 3, and then the motion sensor just has a single pin to tell you when there's motion detected. So that's using 4 pins, which is well within the capabilities of this AT tiny 128. But for now, this is the kind of thing you can do, and either of these 2 boards will quite happily do this. Just if you were going to build it into something you would keep longer term, you just use as big a chip as you need, and this doesn't take up much program space. This one is just using these RGB LEDs as well, the WS2812s, but obviously configured as a star. Now, what did I make this with? Well, it's just a sheet of paper on the top acting as a diffuser. This is just regular photocopy paper. You can see inside there one of the strips, and the box, the star, is literally just a Ferrero Rocher old chocolate container from a present that somebody got, and I just got a hold of the discarded container. It was already in a star shape. Hot melt glued the stars inside, poked some holes in it, put some dividers in there to stop bleed over just from bits of cardboard in here, and put a sheet of white paper on top just to act as a diffuser, and it gives you a nice little star effect. Now, what's running this right now, I didn't even have to write any code. So I will go into my laptop in a moment and show you the code. This is just a set of libraries. In this case, the drivers for this came from Adafruit. They're a company that sells worldwide all sorts of cool electronic gadgets, and they've actually been providing a huge number of drivers for graphical displays. These WS2812s, Adafruit call them NeoPixels. And all it takes in the Arduino IDE is to go into the IDE, add a library called NeoPixel, and I'll show you how to do that in a second. And then this is just one of the demo sketches. You tell it what pin you're connected to. You tell it how many LED elements are connected, and that's really it. And whether it's an RGB or an RGBW type LED strip or something. Anyway, we're going to go out into that in a moment. We're going to take a little step backwards first. Let me just put the overhead lights back on just so we can see a little better. It's probably going to wash out a little bit because I've got the exposure adjusted too. Let me just change that. The code that is running this, right now I've told it to use pin 7 for the output to drive these ones. This little strip of 10 is connected to pin 6, and all it's got is 5 volts. These are driven from 5 volts, and everything else, as I said, is I didn't even have to program, and you can see you can get a little Christmas decoration going quite easily. Other strips, as I mentioned, taking a step back, that you can get to drive. Now you can imagine this little LED that we were driving before. This is one LED. Well, it's technically is 3 inside the package: a red, a green, and a blue. And we limited the current to maybe about 10 milliamps going through it, which is about all that any of these controllers can handle on a pin. But if you wanted to decorate a tree, or maybe under counter lighting, or behind a TV or something like that with colors, then you'd probably want to get something like this. This is a strip of LEDs. These are small LEDs. Let me just bring it up a little bit. These have got little LED chips on them with a resistor every now and again. You can cut these into strips of 3. They run on 12 volts. So it's basically 3, 6, 9 volts because there's multiple chips inside here normally. And you can just cut them in strips and arrange them to make, you know, digital clocks and all sorts of things like that quite easily. This roll probably has maybe 5 meters of this, but these are quite small LEDs. All right, so this whole strip might take about 1 amp to drive it, but you can get ones with bigger LEDs. These are what they call 50-50 size LEDs. You can see there's a few more resistors here per light, and these run on 12 volts as well, but there are 3 LEDs per chip in here. They're all the same color, they're not RGB or anything, and they run off 12 volts as well, and they can get pretty bright. If I just pull this out a little bit and plug it into 12 volts, so we'll just borrow the power that I was using here and plug it in. All right, that's a lot of light, and you can get these in 5 meter lengths on a roll. All right, a lot of LEDs in there, but they're all one color. Okay, very cool. As I said, these will make up good decorations and you'll be able to drive them, but you certainly cannot drive them directly from a pin on here. You would have to have some kind of interface, and we're going to go through that in later videos on how to do one of those interfaces. But for now, we're just going to keep with the logic levels that are coming out here. So we can't drive one of those yet because we don't have enough power. I do have another video that I did quite a while ago that shows you how to interface things to higher voltages and higher powers. I'll leave a link in the description, but I will go over, I will make a refresher of that in lieu of doing this video. All right, just to be more relevant to this. Now, the third kind that you can get are these strips. This strip is Rgb strip, so you've got more wires on the end, as you can see here. Right, you've got red, a green, a blue, and then you've got a common. Now, these also run on 12 volts. Now, this is a little controller that often will come with them. It's a tiny little thing. My infrared remote interface, etc., etc. And you can run these right away, right like this. Let me just put it down here. I'll power it up. Here's a remote control that comes with them sometimes. And you can just plug it in and then turn them on, right? As you can see, all of these LEDs are going crazy. Now I can select any color I want just using the remote. Okay, so green, blue, white. I can make it do patterns. Right, so it'll fade through patterns. Ideal for, you know, Christmassy decorations, Easter, behind the TV, you know, all sorts of things like that. You know, you can do all sorts of different effects with it. So it's running through different effects. But again, you're limited to what is in here, right? Now these, again, they're directly driven. The LEDs are all in parallel, effectively, running on 12 volts. So you can pick red, green, and blue, and any 256 different levels of intensity for each of the colors if you were driving them yourself through a, you know, an 8-bit PWM or something. It's probably got similar number of intensities here. You can actually dim these down with the remote and things too. But wouldn't it be more fun to be able to integrate this into something like your Arduino Uno or your Mega or something like that? And we'll go through that as well. But again, in a later video, I want to cover driving high-powered loads where you need to have some interfacing from your Uno to get to it. We'll cover that again later. So that's where we're going to be going to. For now, I just want to look at driving these strips. So as I said, these are WS2812s. One of the benefits of them, see these ones, when we were looking at these, you pick red, they're all red. You pick green, they're all green. You pick blue, they're all blue. If one's off, they're all off, etc. You can't have one of each LED a different color. Oh, these are waterproof too, by the way. They've got a plastic seal on them, so you could use these outdoors if you wanted to, or in a damp environment without too much worry. Always the same color across the whole board. Nothing much you can do about it. If you wanted to have something more fun, like what's happening with this, all right, let's bring that back on a second. All right, you want to be able to do something like this, where it's running different colors, and even in a minute, it'll change the colors within a cube diamond. Yeah, man. Right, it's fading through all sorts of different colors. If you want to be able to do that, then you need to use a different kind of LED. And these LEDs, the WS2812s, they have a microchip inside them, and you can use one pin from your controller. In this case, it's using pin 7 to talk to this one. And you send out the data as a serial data stream. And depending on how many LEDs you have, you send out the equivalent number of pulses. Now there's 3 LEDs in each package being driven by each one. So 3 LEDs, that means that if you're assuming 24 bits, that's 8 bits per color. And you've got 10 of them on here, that's 240 bits of data. You have to squirt out the interface, and then these will come on, light up in the patterns that you've asked it to do. You can also control the intensity, obviously, by varying the LED intensity individually for the red, green, and blue, right? 8 bits per LED, so that's 24 bits per NeoPixel, which gives you over 16 million different colors. So how do you drive this? So let's get a bit of code up and I will show you. Okay, here we go. I've got the code sitting up here that is currently running on the big star over here. Now, I think what I'll do is I'll just zoom in a little bit there so you can see a bit better. There we go. Okay, so I'm connected with my Arduino programming environment to the Arduino Uno right now. Could equally be the ATmega over there. And what I have here is the Adafruit NeoPixel test program loaded. Now, if you just install your Arduino IDE, you won't have this in. So the way you get it in is you just load a library, and the way you do that is you just go up to the menu, click on Tools, no, Sketch, sorry. You go up to Tools, and then you go down to Manage Libraries. You can just press Control Shift and L, no, I for libraries, anyway. Manage Libraries. If you go in here, it'll bring up the screen. And these are all the libraries that are available to you. Now, you don't want to have to wade through too much of this. So go in the search thing and just type Neo, N-E-O-P-I-X-E-L, NeoPixel. It will go and do a search, and what you'll find is a bunch of different things that mention the word NeoPixel. The one I installed is the third one that should be in your list, and it says installed on mine. The Neo Matrix is also in. That's a different kind of board altogether. Adafruit NeoPixel by Adafruit version 1.3.4 is the one that I've installed, and you can see here it shows it's already installed. All right, so if you haven't, you would just go to the either update, or well, you hit install to install it on this one here. All right, follow any prompts that you might get. Once it's installed, you can then go to you can go to File, Examples, and scroll down, and you should see a section called Adafruit NeoPixel now, and to the right of it you've got things like button cycler, Rgb strand test, simple new operator, wheel, callback, like all different versions of this. The one I picked was RGBW strand test. Okay, so we'll go back in there. Right, examples, and we want NeoPixel RGBW strand test. Now I don't have RGBWs on here; these are just RGB. But that's okay. This code, here's the example, right? It shows us that we've got the library loaded. I'm not going to go into too much detail for every one of these. Remember we talked about defining pins earlier in the previous video. Well, here is an example where we define the LED pin as pin, well, the star was on pin 7. I'm going to change this to 6 because that's this little strip just here. And the next one tells you how many LEDs you've got, right? Now the star has 50 because it's got 5 points with 10 on each one. This only is one of them, and it's only got 10 in there, so we'll just say 10. And then you can tell it the maximum brightness. If you've got a power supply, for example, that can't provide too much power, you could bring the brightness down and reduce how much current is being used. I've got it set to maximum right now. And that's all I did to actually use this. I left everything else alone, except for one thing. I changed here where it says Neo Grb. Originally it said GRBW, which was the one with the white LED in the chip as well. I only have the RGB, not the RGBW. So you can see down here you've got GRB, RGB, or RGBW. I would imagine that RGB would work with the ones I have here too, as it's not really doing anything weird. It seems to be working just fine. And you just you just take the string that's here, depending on the NeoPixel you have, and replace this string up here with it. Alright, so as you can see here, I've done Neo GRB. So how this program works, in setup, it initializes and then starts the show and then sets the brightness. So begin, we'll just initialize a whole bunch of background things. This is calling some of the libraries that were brought in when we did that little tools, manage libraries, searched for NeoPixel and installed the library. That allows all of this stuff to now be used. And then it just has a loop here which does a color wipe, four color wipes. All right, so you've got red, green, blue, and then white if you've got white. Well, it'll do white just by using RGB. If you have a strip that has a true white, then it would use the white LED. Then it does a white over rainbow, a pulsing on the white, and then a rainbow fade. And that's it. It just loops through those few little effects, and away it goes. So if now I've changed the code to use this little strip here, if I just say compile and upload, so we're compiling now. Okay, now it's uploading. There we go. And now we've got this strip working, right? And it's just following that sequence. Nice and simple. So, what else can you do with things like this? Well, you can actually have these work as VU meters. You could have each individual one being a status indicator. The nice thing is that when you have a project and you want to have lots of RGB lights and things like that, you don't have to take up a lot of pins. If you remember in the previous video when we were using this, I mentioned that if you wanted to have 60 LEDs all running, that would be 3 wires, 3 I/O lines times 60 LEDs, so you've got 180 I/O lines. Well, that even the ATmega 2560 doesn't have that. So you could use a whole bunch of chips to expand the I/O capability. Excuse me. You could use a whole bunch of chips to expand the I/O capability of the Arduino, but that gets expensive. There's a lot of wiring and everything else. And why would you do that when you can get your RGB LED and the expander chip and everything all in one neat little package, and you can just serially daisy chain them like this. Now you can also buy these already daisy chained. I have one here somewhere. This. Nope, not that one. Here. All right, this one is 60 of these NeoPixels. You can see there's one in every chip there. You can cut these as well if you wanted to lay these out in a magic mirror or some kind of picture frame, whatever you wanted to do with them. All you have to do is cut where the copper marks are, and you can then run wires and just change the shape. They've all got 3M adhesive on the back so you can stick them down easily. But this is exactly the same as what this is, except this is on a hard PCB. These are on a strip, and you can buy these ready made up in these strips with the ends on. You've got power, and then you can connect this into your controller and run this. Now the nice thing is that all you have to do is give this power separately, and it's running on 5 volt in this case. Those other ones I showed you run in 12 volts. This runs at 5, and it uses a 5 volt data input to drive each of these, to signal them. So it's it's a normal logic load, so it's well within the capabilities of any of these microcontrollers to clock the data on these. And the nice thing is you can even make these run, if you put this in a great big circle, right, you could make it run as an RGB clock if you wanted to. And there's actually a library out there already for an ESP8266 that lets you do that. So for now, I really wanted to keep this very, very simple. And what I'm showed you here is the fact that just loading a library and running a demo display, a demo script, you can get a Christmas decoration up and running really, really easy. Now, I used an old Ferrero Rocher chocolate container here, but you could use any shape you like. You make your own shape up. You could do it in the shape of a tree, whatever you like. Just tell it how many pixels you've got and away you go. And an examination of the code here lets you see how you can change your functions. And the code down here is all here for each of these other routines, and it's a little bit more advanced in the programming than where we're at right now, for sure. And I will be going through it at some later date, but not for now. What I wanted to show you is just a simple way of getting something up and running, but not necessarily having to understand too much about the lower level workings of it. You can buy these on strips, like I showed you, these ones here, at Banggood and lots of other places. I'll provide some links in the description. They work on 5 volts, so you will need something like a 5 volt at several amps if you're going to have a lot of strips. If you're just going to have 4 or 5 of them, then just a little USB type adapter would probably work. But if you're going to have, you know, 120 or more of them, then if you think about it, 60 LEDs, 3 actual LED chips per LED, so that's 180 LEDs at 20 milliamps, or between 10 and 20 milliamps each. 60 milliamps per LED, so 6 sixes, so that's 3.6 amps, right? A lot of current that you would have to drive if you were having them on full brightness. But perfectly doable, and you don't need any special drivers. You just need the power supply, you need the Uno, a little bit of code like we showed you in the sketch, and you just hook up one of the pins to the data line, you give your 5 volts to the strip, and away you go, done. And then you just got to tape it together in a form that you want for your decoration. If you just want to wrap it around a tube, you could do that too. Works just as well. It's like a decorative lamp or something like that. If you had a cardboard tree, right, and you just wanted to spiral it down the tree, you could do that as well. You can actually daisy chain these as well. This is a 60 strip, but it has a plug and a socket pre-wired on the ends. So if you've got another strip, you can just plug it in and tell the code you've got now 120 LEDs instead of 60 LEDs, and now it'll drive both of them. Now be aware that if you do a really long strip, maybe 5 meters or more, then the LEDs at the very end might be starting to be a bit dimmer, because the 5 volts at that current is having to go all the way down the strip to get to them. So you might be in a situation where you might want to power some of them from the other end as well in order to keep the brightness up. But again, that's getting a little bit more advanced. So just keep it simple. Keep it on some smaller runs and things, and you'll just be fine. Anyway, that's pretty much it that I wanted to show you for this video. As I said, nice, neat, easy to make little Christmas decorations. I mean, you could put something like this inside a gingerbread house, right? You could have the individual strips from one of those strips cut up and put in the windows of something, maybe an advent calendar, and they light up each day and stuff like that, right? Lots of different opportunities. So anyway, give me your ideas. Let me know what you're going to do with it, if you're going to do anything. I'll provide links so that you can buy the Uno R3 developer kit, or just the R3 if you want to. I will also provide some links to where you can get some of these LED strips from. The links will be to Banggood. I'll use an affiliate link, so they won't cost you any more money, but I will get a little bit of commission, help me run the channel, do these videos. And yeah, happy decoration making. See you in the next video. We'll be going into a bit more details. Bye for now. Oh, if you like the video, give it a thumbs up. Don't forget. Thanks. Bye. And subscribe. Before I go, I'm going to put right after I've spoken here, there will be a very short video from the competition that I had done a few years ago, which shows all of these and other things all working together. A whole bunch of different things I did with driving LEDs, etc., etc., as part of a Christmas, December holiday, whatever you want to call it, contest with LED lights and things like that. It's only a few minutes long, but you'll find it quite entertaining. And yes, I do have a thing for minions. Bye.
Pakoy. Ah! Pakoy!